Hey everybody, hope you guys are doing well. So we get to start a new unit today, and this new unit is going to be focused on what we call trigonometric identities. Now, what is an identity? An identity is simply a statement of equality where we have something here equals something else, right? But those two things are equivalent. They're the same, they just look a little bit different. All right. Now we actually know quite a few identities already, and I'm going to put them up on the board. I already wrote them out for you, and you guys should recognize all of these. Okay. So first off, this is an identity that the tangent of x equals the sine of x over the cosine of x. Okay. Those two things are equivalent. They're just two different ways of writing the same exact thing. And that's called our tangent identity. Now you'll recognize these as well. These are what we call our reciprocal identities, that the cosecant of x is 1 over the sine of x. It's the reciprocal of the sine, and so on. So we have our tangent identity. We have our reciprocal identities. Now take a look at these. Okay? Hopefully you recognize these as well. The cosine of negative x equals the cosine of x. Okay? Why is that true? It's true because cosine is an even function. Okay? We looked at that quite a while ago. We know that sine is an odd function. So the sine of negative x equals negative sine of x. Tangent is also odd. The tangent of negative x equals the negative tangent of x. Okay, and then the same with our reciprocal functions over here. These are even and odd identities. So there's some things here that we already know. What we're going to be doing in this unit is we're going to be expanding these to a lot of identities. And these identities, I hope you're going to find out that eventually that they are very useful. We're going to have a lot of practice on simplifying. So here's an expression. Can we use some identities to simplify that expression? We'll be also be doing some verifying, proving, showing identities are true, where we have a statement already. We have to actually show, is that really true? These identities will show up in lots of different places in the future. Really helpful. I know in calculus, oftentimes we were going to rely on some of the identities that we're actually going to look at today. I'm thinking about my my calculus students who have been working on something called integration, and we have been using what we call the Pythagorean identities to really help us find those integrals. So Pythagorean identities, what is that about? Okay. Well, here I have a circle drawn. Let's just say it's the unit circle, and let's just let's go with a different color there. Let's make that a little bit bigger. There we go. And let's just draw a triangle in here. Now, if this is the unit circle, this of course is 1. Let's call this angle x. Now then, what do we know? I know oftentimes we use thetas there. We could use a theta and that would be fine, but I'm going to write a lot of my identities with an x instead of a theta. Well, what do we know? Well, we know that this side is the cosine of that angle, that this is the cosine of x. This side is the sine of x, right? I mean, isn't this point the cosine of x, the sine of x, right? Okay. So this is what our triangle looks like. Now, what type of triangle is it? It's a right triangle. And if it's a right triangle, what can we use? We can use the Pythagorean theorem to write a statement here. And the Pythagorean theorem would say we're going to take the cosine squared plus the sine squared, and that has to equal 1 squared, which of course is just 1. Okay. This is our first Pythagorean identity, that the cosine squared plus the sine squared is equal to 1. Okay. Now, I wrote this here a little bit different. I just put it in the other order, but of course with addition, the order doesn't matter. Now notice we can write the cosine of x squared this way, but we also have a shorthand way of writing that, where we write and we put the squared there. Okay. Kind of saves us that extra work of writing those parentheses. We can do the same thing with the sine. Now, why do we put it there and not just here? Well, if I write the squared there, it would look like the x is being squared, that the angle is being squared, and that's not the case. That's why we put it here. Okay? So we have the sine squared of x plus the cosine squared of x equals 1. Okay. Now, is that always true? Well, is that true for every point on this circle? And the answer to that, of course, is yes. That's true, right? If I draw the triangle over here, our sides of our triangle are still cosine and sine, and we still have that right triangle where we can write the Pythagorean identity. Okay, so this is a huge identity. This is one of our favorite identities, one that we use quite a bit, and it's just got to be engraved in your mind for the future. Okay, super useful. Now, we have a couple other Pythagorean identities. Our next one that I'm going to share is 1 plus the tangent squared of x equals the secant squared of x. So using other trig functions instead of sine and cosine, this shows a relationship between tangent and secant. And does it still have a Pythagorean theorem feel to it? I think it does. Now, it's not the same where we have something squared plus something squared equals 1, but notice this is still 1 squared, this is tangent squared, this is secant squared. We have the sum of two squares equal to another square. And don't panic, we'll get to why that one's true, of course. And our last Pythagorean identity is 1 plus the cotangent squared equals the cosecant squared, which also has that Pythagorean feel to it. 1 squared plus cotangent squared equals cosecant squared. All right? So, what do we need to do here first? Well, I almost jumped ahead of myself here. One thing that we have to realize is that this is one way to write this Pythagorean identity, but there's actually alternative ways to write it as well. Okay? And we have to be familiar with those. And I mentioned my calc students already having to use the Pythagorean identities. Oftentimes they don't use them exactly the way that we saw them on that last page, but we use alternate forms of the Pythagorean identities. So see if you agree with me on this one. If the sine squared plus the cosine squared equals 1, doesn't the sine squared equal 1 minus the cosine squared? All I did is subtract cosine squared on both sides, and we get that identity. We also have the cosine squared equals 1 minus the sine squared. Okay? If I take our original Pythagorean identity and I subtract sine squared on both sides, I get this. So these are two alternate forms of that Pythagorean identity, and these are very useful too because we don't always see them show up quite like this. How about the alternate forms for our other identities? Our next one was 1 plus tangent squared equals secant squared. Well, if I manipulate this around a little bit, I can write things like 1 equals the secant squared minus the tangent squared. I can write it as the tangent squared equals the secant squared minus 1. That's a pretty common alternate form of this identity. And there we have it. So those are our alternate forms for that one. What was our last identity? 1 plus cotangent squared equals cosecant squared. Okay. Alternate forms for this would be 1 equals cosecant squared minus cotangent squared, and then cotangent squared equals cosecant squared minus 1. Okay, all we're doing is just subtracting, solving for a different piece of that Pythagorean identity. All right, so let's get to a fun thing here. Okay, let's actually show that this is true. Okay, let's show that 1 plus the tangent squared equals the secant squared is actually true. Now, with the sine and cosine identity, that made sense to us. We looked at the unit circle, we looked at the triangles, and it just made sense here. But how about this one? Why does this make sense? Okay. Well, let's prove that it's true. Let's show that it's true. So I could use the word prove, show, verify. They all work. Now, one of our rules when we are showing an identity is true is that we're only allowed to work on the separate sides of the equal sign individually until we show that they're the same. I'm not allowed to do something like multiply both sides by 2 or square both sides, things like that. I just want to work on one side and make it look like the other. Okay? That's the main way. Now, it is possible to work on the left and work on the right, and then eventually they end up being the same thing. But my preferred method is we just pick one side and we make it look like the other. And that's what I want to do on this one. Let's start with the left side, and let's show that the left side is really the secant squared. So when I do this, it's really important that we stay organized, and I want things to be in line. So I want that equal sign to always be in line here. Okay, so let's start with this. Okay, over the course of the next many videos, I'm going to be giving lots of hints on how to verify or show that identities are true. One of the biggest hints that I can always give you is that oftentimes it's much easier to work in terms of sine and cosine. Okay, those are my favorites, and I think they'll be your favorites too. Is if you're stuck and you're not sure what to do, change everything to sines and cosines, right? I mean, if you go back to what these identities that we already know, we know that tangent is sine over cosine. Okay, we can change cosecant to 1 over sine. We can take any of our trig functions and change them into sines and cosines. So let's do that. Let's write this as 1 plus, well, tangent is sine over cosine. Okay, so I'm going to write it like that. I'm not going to do anything with that left side. That left side stays exactly the same. Now, it is okay to do this, right? If we're taking sine over cosine and squaring it, a different way to write that, and I think you guys would probably like this better, is to just write it as the sine squared of x over the cosine squared of x. All right. Okay. Now, as I work with this here, I'm going to take a peek at this right side and try to think, where am I trying to get? And I'm not going to write this down as part of my proof, but what do I know about secant squared? Well, I know secant is 1 over cosine. So secant squared is 1 over cosine squared. So if I can get that left side to be 1 over cosine squared, I've got it, right? Hey, well, notice I already have a cosine squared in the denominator here. So I'm already kind of excited that I think I can make this happen. But how do I do that? Well, what I'm going to do is realize here that I'm adding two things together. And this one is a fraction. It has a denominator. And if I want to add two things together, I need to have a common denominator. So what I'm going to do is I'm going to rewrite 1, okay, with a denominator of cosine squared. Okay, that would be a common denominator. So how do I do that? Well, 1 is cosine squared over cosine squared. All right? Okay. So I got a common denominator. Now I can add them together. Okay, my denominator is the cosine squared of x. My numerator is the cosine squared of x plus the sine squared of x, right? And we have two fractions, denominator is the same, we just add their numerators. All right. Now remember, this is my goal up here to get to. Now take a look at what we have, and I hope you see what we've got here. What do we have in the numerator? Cosine squared plus sine squared. What do we want in the numerator? We want a 1. Well, what do we know about cosine squared plus sine squared? It's equal to 1. That's our original Pythagorean identity. So we can substitute and say, you know what? That numerator is really 1. So we have 1 over the cosine squared. And we know 1 over the cosine squared has to be the secant squared. So we end with this step. Okay, the secant squared of x equals the secant squared of x. Notice we only worked on the left side, and eventually we got that left side to be secant squared, which is the same as the right side. We have just shown that that is true. Okay, isn't that fun? Okay, I think that's a blast. We're going to work a lot more on this. In your next video, we're actually going to focus more on just the simplifying part. Thanks for watching. Let's start to work with these Pythagorean identities.